Hello everyone and welcome to our next video. So today I want to give you a project, and this project is going to be a little bit confusing. We're going to be using a project using forward kinematics, and you can find all the information about this at gm0.org. So what this project is we are going to take we're going to be using a Mecanum drive, and there are 4 wheels on a Mecanum drive, right? So we're going to be taking those 4 wheels. Here, I'm going to draw it right here. Let's draw it a little smaller. So right here, we have a Mecanum drive. Right here. It's going to be a perfectly square Mecanum drive, and we're going to be taking the wheels, the velocities of each wheel, like this, and we're going to be calculating how fast our robot is rotating at. So let's imagine we have it right here, and just like that, we're going to be calculating the velocity. So with this project, you're probably going to need a little bit of help because you probably don't know the formula for how to figure this out. So I'm going to be giving it to you right now. The formula is, um, what is it, omega, and this is a Greek letter, and this is in radians, by the way, radians per second, I mean. So you might not know what radians are, but they're basically another unit for measuring angles. So, like for example, we have degrees, and there's 360 degrees. So we're going to be converting these radians later because we want our answer in degrees. But for now, we're going to ignore that, and I'll get back to that in just a second. So this is our omega. Our radians per second is going to be equal to the velocity of the back right motor. So basically the velocity of this one, meaning if it's going up, it's going to be +1, or let's say it's going to be in inches per second, by the way. So if we're going this way at 1 inch per second, that's going to be 1, and if we're going this way at -1 inch per second, that's going to be -1. And it could be more than that or less than that, however fast the robot happens to be going. So the velocity of back right plus the velocity of front right minus the velocity of front left minus the velocity of back left. And so we're going to take all of these and do that divided by 4 times 2, t, my bad. So t right here is going to represent the track width. So this track width is the distance from here to here, or you could say it's the distance from here to here since we're using a square drivetrain. So that is our t, is this distance right here, and it's going to be measured in inches. So t is in inches, inches per second, radians per second. And this right here is also t as well. They're both the same distance, of course. So after we have calculated our angular velocity in radians, we're going to want to convert that to degrees. Now, you might remember before we used the math class in order to do the math.pow function, which let us raise something to a power. So this time we're going to be using a new function in the math class, the math.2degrees function. And you're going to put in your omega right here. So that's going to convert this from radians per second to degrees per second. And then finally, we're going to print out the result onto the screen. So one thing about this problem, since there's so many things, you're going to want to prompt the user just like we've done before, like what are you asking for, what units, all those types of things. And one last thing, there's so many different solutions to this problem. Everybody's going to have different solutions, even though we have the equation right here. So don't worry if your solution happens to be a bit different. And this problem might be a little bit more tricky than it looks like right on the surface here, but I'm sure you all can do it. You're amazing.